Okay, lesson set 20 is going to deal with related angles and signs of trigonometric functions or trig functions. So the first thing I want to do is just refresh your memory of how to change this polar coordinate format of 12 at an angle measure of 135 into a rectangular coordinate system. So you always start at 0 degrees, which is on the positive x-axis of the xy coordinate system. So I want to start at 0 degrees, and I'm going to move around 135 degrees, which puts you into the second quadrant. And then that 12 is referring to the distance that you go after you pivot 135 degrees. Now if I take 180, which is the straight line, and I subtract the 135 degrees, which is how far we pivoted, that's going to be the remainder, or that difference is going to be the angle inside your triangle. So we find out that 180 minus 135 has a value of 45. So I have a 45 degree angle. This is a right triangle because whenever we are drawing our, they say related angles, I like to refer to them as reference angles. Remember that I said whenever you draw those reference angles, you are using the bow tie effect. So you always need to go, sorry, my hand was in the road, you always need to go and draw straight down or up or whatever to that x-axis. We do not wear our bow tie like this. So our reference angles will always be in reference to the x-axis and not to the y-axis. So I have a 45 degree reference angle, and I know that in order to change this into rectangular coordinate system, we know that the cosine of x is equal to, well, 45 degrees, that is my angle, sorry. The cosine of 45 degrees is equal to the adjacent side over the hypotenuse. So to find x, I'm going to take 12 times the cosine of 45. Now, some of you are probably just going to type that in on your calculator, but you're going to get a value of 8.48 when you type it in on your calculator. Now we could do that in terms of radicals, because we know that the cosine of 45, if you use the hand trick, so we have, if I can get my whole hand in there, you have 45 degrees, and the cosine of that is radical 2 over 2. So we would have 12 times radical 2 over 2, and that would give you a value of 6 radical 2. Now we like to leave it though probably in the decimal format, although one of you, you do happen to leave it in radical format, and I accept that. Now the other thing you would do is you would find y. So to find y, we know that the sine of 45 degrees is equal to the opposite over the hypotenuse. So that would be 12 times the sine of 45 degrees, and once again that's going to give you a value of 8.48, because we notice that if you have 45 degrees, this will also be 45 degrees because it's a 45 45 90 triangle or isosceles, so that makes sense that it has the same value. However, when we go to write that in rectangular coordinate system, when we write it in rectangular format, what we notice is that the x value happens to be negative. So we're going to have negative 8.48 I, and then the y value is positive, so it's plus 8.48 j. Now that leads us to what this whole lesson is talking about, and your book actually goes through and explains a whole bunch of different things, but we are just looking at the x and the y, the sine and the cosine, and then you could deal with tangent in every single one of the quadrants. So in this case, in the second quadrant, I notice that the x value, or my cosine value, is negative, and the y value, which is sine, is positive. Now if I talk about tangent, one thing to notice about tangent, we're used to tangent being SOHCAHTOA, some old hippie caught another hippie, tripping on acid. So some of you know it as opposite over adjacent. But keep in mind that also means the same thing as sine over cosine. And the reason for that is because sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And if you invert and multiply, so I'm going to multiply by hypotenuse over adjacent, then the hypotenuses cancel and you are left with opposite over adjacent, which is what we know when we say SOHCAHTOA. So if I look at the sine, if I want to know what is the sine value of a tangent in the second quadrant, our tangent values of any angle measure between 90 and 180, is that going to be positive or negative? We notice that sine is going to be positive and cosine will be negative, and a positive divided by a negative is a negative. So in this second quadrant, we know this information. We know this from what we just talked about. In the second quadrant, we found out that sine was positive. We said cosine, which is your x value, is negative. And then we said, well, tangent is a combination of those, or you divide the two, and you end up with a negative value. So an easier method that I have in order to remember what quadrants are positive and negative, and I think I've shown you this before, we think of the phrase, and we're just going to start at 0 degrees again as if I were drawing a reference angle, and I just say that all students take calculus. And you just write it in the counterclockwise direction. All students take calculus. Now what that says is sine, cosine, and tangent will all be positive in this quadrant. The only thing positive in the second quadrant is sine. Sine is the only thing positive. In the third quadrant, tangent is the only thing that will be positive. Both cosine and sine are negative, and a negative divided by a negative gives you tangent, which is positive. And in the last quadrant, we have calculus, which is going to tell you that cosine is what's going to be positive. Now another way that you could look at it, and it's the way that I used to look at it, is we talk about the normal sine and cosine curve. If we talk about the sine curve is going to look like this. And in that sine curve, we could talk about 90 degrees. Here's 180, and here is 270. And right here is going to be 360. So if you look at the values, we talk about between 0 and 90 degrees is quadrant 1. 90 to 180 is quadrant 2. 180 to 270 is quadrant 3. And then you have quadrant 4. So you can see that sine is positive in the first two quadrants and negative in the last two quadrants. If you look at the cosine curve, same thing with the cosine curve, it ranges from 1 to -1. And if you deal with the cosine curve, it's the smiley face. So you have quadrant 1. We're going to split this, and you have quadrant 2, quadrant 3, and here's quadrant 4. So cosine is positive in the first and the fourth quadrants because those are above that x-axis or the value of 0. Now tangent, the tangent curve gets a little more complicated, and as you start to look at the tangent curve, you start to get values like this. You have some values that are undefined because wherever cosine is 0, such as the cosine of 180 degrees, which would be found right here, the cosine, if this is 180 degrees, you're going to have the sine of 180 divided by the cosine of 180. So the sine of 180 degrees, now I got it wrong, it's not 180, is not undefined. I should say 90 degrees right here. Got to going too fast here, sorry about that. So there's 90 degrees. So if you talk about it, you look at the sine of 90 degrees is 1, and you're dividing by the cosine of 90 degrees, which is 0, and that is undefined. So I just sketched my line there. It's still at the right spot, because here is 0, here's your first quadrant, here's 90 degrees, and then that's not positioned very well right there, but it's going to curve like this. So then here is 270, and then you're going to have your dashed line, which is going to be undefined at 360, and then get your curve again. So to me, it's easier just to look at the sine and cosine values and determine what is the positive divided by a negative, or a negative divided by a negative. Or even better yet, I just refer to all students take calculus. I used to look at the graphs a lot and look at where they landed in the curve, but all students take calculus. Sine, cosine, tangent are positive in the first quadrant. Sine is the only one positive in the second quadrant. Tangent is the only function positive in the third quadrant, and cosine in the fourth quadrant. Now eventually we will get into cosecant and cosine, cosecant and secant and cotangent, and those will correspond with their same values here, because they are just reciprocals of each other. Okay, I'm going to go ahead and stop this video. It's right around 11 minutes, and I'm going to go create another video of the 3 examples and maybe include a problem on your homework assignment.